Another reason for high L2 retries is the mismatched power setting. Now this settings is between the APs and the clients. Okay, now imagine this. I have an access point here, and this is the BSS, or the coverage area of the access point. My access point is transmitting, for example, at 100 milliwatt, and my client at the corner is transmitting the signal at the power level of 20 milliwatts. Okay, 20 milliwatts. Now the communication between the client and the AP can literally break down if there is this much difference in the power level of the client and the access point. I'll tell you how this really happens. Now when the access point transmits a frame to the client, the power level is very high and the frame gets received just fine. There is an ACK that is sent and the AP says okay, absolutely good. Now when the client is trying to send a frame to the AP, the power level is so low that when the frame reaches the AP is not able to comprehend the frame. Okay, there is something called received sensitivity value, which means you need a minimum amount of this much signal strength for the destination to decode that signal. Okay, that is called received sensitivity. So when the signal is received by the AP, it is way below the received sensitivity of the AP, which means the AP cannot decode the signal. Okay, that's pretty much what it means. Whereas when the AP sends the signal, the receive sensitivity of the client is well within the range of the frame RSSI value that comes to the client. Now here, if the AP cannot decode the frame, the AP will not send an ACK. Once the AP does not send the ACK, the client thinks my traffic was not received, hence there will be a retry or a retransmission happening, which means the L2 retries will increase in the network, right? And this is a big concern. In fact, used to be a big concern, still is in many networks, because I'll tell you why this was the case. Long back, the networks used to be deployed, the APs used to be blasting at the maximum power. When you deploy a network and you want to give maximum coverage to increase the range, usually network admins and network design people deploy an AP and start blasting it at the maximum power, which is a very, very bad idea. Never do that. Okay, in fact, you got to make sure that if there are APs and there are clients around it, right, then you got to make sure that the maximum transmitting power of an AP, okay, let me quickly change this. Yeah, the maximum transmitting power of an AP should be, let's say this is 60 milliwatt, this is 50 milliwatt, this is 30 milliwatt, and this is 40 milliwatt. Now the maximum transmitting power on an access point should not be more than 30 milliwatts. Okay, this is in a network where there are clients with different transmitting powers. Usually in a network, in a corporate, when you have same built laptops and so you have all the clients transmitting at the same power. So the best way to do it is make sure the transmit power of the client matches the transmit power of the AP, or all the APs and all the clients. If you design the network this way, you're good. You will not have any mismatched power settings problem in the network, and your client should actually function just fine, right? Now this has kind of believed to cause a lot of issues in the network. One way to test this and figure out if there's a mismatched power setting going on is with the help of, now this was the fix. Okay, now how can you really figure out if there's a mismatch problem going on is if you use a protocol analyzer. I would suggest Wireshark, which is what I always use. Okay, now there's an access point here, there is a client here, client A. Now if you take a protocol analyzer and packet, let's say this is 100 milliwatt transmitting, this is 20 milliwatt transmitting. Now if you take a protocol analyzer and move your laptop near this AP and try to capture the frames here with the protocol analyzer going on, okay, you will be able to see the frames coming from the access from the client getting captured here. They will be, you know, they'll kind of be corrupted, okay, not captured properly. Whereas when you move the protocol analyzer here and try to take the same capture near the client, it will receive traffic coming from an access point. The source of the frame should be the access point's MAC address. You will not see the frames getting corrupted in the protocol analyzer. This shows that yes, there is a mismatch of power level between the AP and the client, right? And wherever there's a corruption of frame, we all know that, you know, the retransmissions will happen, and the layer 2 retries are gonna drastically go up. Now this has been a major issue in the voice over Wi-Fi or VoIP traffic, because many vendors kind of, you know, change the power level of an access point on their own, and this can cause huge problem in the difference in the power level of an access point and a client again. And a client being a voice client, you know, they are very much prone to these issues. And when there's a problem in the mismatch power, when there's a problem in the power level, you can actually expect some choppy audio, and the call can even get dropped if there's too much of a power level difference, right? So you can expect choppy audio in voice, and sometimes the call can entirely drop, which is the drastic, if the condition is too drastic, the voice call can even drop, and, you know, this can actually cause a lot of issues in the network. So yeah, so make sure you keep this in mind, and again, the design consideration should be that the power level of the clients and the AP should actually match as much as they can. Or if there's a heterogeneous environment where you do see a lot of clients on different power levels, and so make sure you have the maximum power of the AP set to the minimum power of any client, like whatever the client's lowest transmitting power of the client, you should set it to that, so that, you know, even if you have a range of, in RRM you define a range for transmitting power, let's say you define whatever range, the maximum range here should be 30, so it should be around, you know, 10 to 30 whatever milliwatts that you set, something like that. So that's how you should design your network, and, you know, you should not run into any mismatch power level problems, right? Anyway, good. So we're going to move to the next video, and in that we're going to talk something like near far, which is similar to this, but still a lot different. So yeah, see you in the next video, guys.